So I went ahead and made the faster version of this rect method here, and it's a little more efficient because if rotation is 0, it completely skips doing any rotation calculations, and all we do is stretch the pixel out horizontally or vertically to make up each line. This is the horizontal and vertical scaling. I changed the name of it to rect lines to distinguish it between this version, and I added these overloads here, so you can just specify a rectangle color and a thickness or an offset position of the rectangle, and it'll use rect lines. So drawing a filled rect in this example here can be used to create a semi-transparent dark backdrop behind your text, for example, and then that way the text is easier to read. Something like draw color quad is going to be useful for drawing gradient blends. So let's go back into game 1, and under sprite batch we'll add a quad batch, and we'll go down to initialize and initialize it. So right here after screen center, let's add quad batch, use new quad batch, pass in the content manager, graphics device, we'll say quad effect. That'll be the effects file that'll handle drawing quads normally, just like the one that sprite batch uses. We'll make that here in a second. Pass in the font texture, which we've added to our content folder already, so long as this name matches what you put in there. The screen dimensions, screen width and screen height that we desire for the render target. For our purposes, we could use quad batch in place of sprite batch. For this tutorial, we're not going to. We're just going to use quad batch for the distortable sprites being used in the Meow Motion animations. And let's go down to draw and test some things out. Before you try to go ahead and test anything, we got to make sure we create an effects file for our quad effect. Our default effect file for quad batch. It'll be just like sprite batches. To do that, let's say new file, and it'll be a shader file, and we'll save this as an effects file actually. We'll go right into content and save it as QuadEffect.fx. We'll need a sampler. First register is going to be S0. Texture equals texture. So this would be our sprite sheet with the name of texture. We'll set some default flags, such as the UV addresses to clamp rather than wrap or something like that. And also by default, our filters. We don't need to set the MIP filter, but I mean you could, it doesn't hurt. By default our filters are going to be linear, so linear clamping. And for our vertex shader we're going to pass in a 4x4 float matrix transform. So that's the transformation matrix that places the vertices where they need to be on the screen. So when we set that world transformation matrix to identity, that means that it's not going to move them in the world. And then the projection and viewing matrix determine how the vertices are translated from the three-dimensional universe onto the screen. We're using orthographic off-center, which means that it isn't scaled based on depth, so it's just going to take the vertices wherever they are in your XY coordinates, and it's just going to put them directly on the screen without considering depth for scaling them relative to the center of the screen. In other words, it's completely two-dimensional. Technically, you could use a 3D camera and do your 2D game so that it's actually in 3D. So back into the QuadEffect.fx, I'll set up a structure and I'll call it Vertex Shader Output. This is the matching format to our desired vertex declaration. 4 floats for color. Keep in mind, even though we're using 4 floating points, the accuracy is only 0 to 255, so each one is represented as a byte before it's made into a float and passed through. So if you try to use some high precision floating point number in your red, green, blue, or alpha value, it doesn't actually translate to actual floating point precision when it gets into the shader. If you're trying to do a complicated shader that takes advantage of the color value to pass in other information, that's for more advanced shading, which we might get into. So the vertex shader will return a position, a color, and a texture coordinate to pass to the vertex shader once it's done making its calculations. We'll call this one sprite vertex shader, and it takes a position, color, and you'll notice this is exactly the same as this structure here. We could even have used this if we wanted. Float 2, text chord. You have to make sure these are in the right order. They match your vertex declaration. And then when you do your pixel shader, you have to also make sure these are exactly the same for what it's accepting. So this is an example of a vertex declaration. Vertex, position, color, texture. That's the format we're using, so that's what we'll need. When end is called and we draw user indexed primitives, inside this angle bracket here, that's where we place our vertex declaration, and that way it knows what format it should be using. Output is what we're going to return. Let's start filling in the values. We'll set the output position to be the position of the vertex, and it will be equal to position multiplied by the transformation matrix that we pass in. So if you look in QuadBatch here, just before we draw our primitives, after we've set our vertex buffer, we apply our technique and we set the parameter called matrix transform, which you see in the effects file right here, matrix transform, that's how it knows what it's looking for, to the value of our worldview projection matrix, which does our worldview projection transformations. We'll set output.color, this is just color, texture coordinate equal to the texture coordinate, no modifications. And then we can just return output, which is in this format. You'll notice the only thing we made any modifications to in our vertex shader here this time is the position based on the matrix transformation. Okay, I just realized that this is a bit redundant, so we can delete that line of code without any consequence. And we'll return a float for, which is a color for the pixel shader, using the exact same format, the format here as input. And now you may be wondering about this formatting here, SV target 0. This is actually exactly the same as saying color 0. In fact, you may want to just leave it as color 0. I only put it as V target 0 so that if you see that in somebody else's shader code, you'll know what it's referring to actually is a color, just like this. If you prefer, and you probably should, you may want to change this to color 0 just to avoid confusion. We could say float for color, figure out the color equals text 2D. Note that the D is capital, the other letters are small, but instead I'm just going to say return text 2D, text sampler. So we're getting a pixel color at a texture coordinate. The texture coordinate is going to be text coord, which is pumped into our sprite shader in this input here. So as the UVs are interpolated across the polygon, it's going to keep submitting another UV coordinate extracting from a different texture point. That's your sampling from our texture, and our texture sampler we call text sampler, and this is what does your texture sampling. And then we'll use a multiplication against the color. If you're using color.white, your red, green, blue, and alpha channels will all be multiplied by the RGBA values in your input color. If all four corners of your polygon are white, then all these values would be 100%, because this sort of ranges from 0 to 1. So at 0.5, it's going to be 50%, 1, it's going to be 100%. You get the idea. If you were to submit a color of red, then the green and blue values are going to be multiplied by 0 if it's pure red, and only the red values would really show through in this texture color. So that way you could sort of tint it. However, that doesn't work very well if there's no red values, because if there's no red values in the original color, then it would be black. So you want to make sure there's at least some RG or B values when you're going to try to tint something a pure color. Or just don't tint it a pure color. Make it a gray with a slightly redder tint. And that's if you're using an extra color for colorizing things. Instead of white, you're using a different color. If you want to do gradient coloring, meaning say you wanted it to be purple on the top and black on the bottom, then the top two vertices, you'd give it a more purple value, and on the bottom two vertices, you'd make it 0. So then as it interpolates across the polygons, the input color value will change as it goes across the polygon in a gradient fashion as it interpolates, and then that value is multiplied here. So it does like a blended shading across the texture based on those color values. Okay, we'll also need to specify the technique. So when we say technique apply, this is where it's going to look. So we'll declare the vertex shader, compile, vertex shader 3.0. Version 3.0 means that we're using OpenGL. If we were using, say, 4 or 5, then that would be DirectX. And that doesn't mean that they're newer versions of the shaders necessarily. It just means that these are the OpenGL shaders, so when it compiles it, it'll translate to a HLSL before it completes compiling it. And make sure these names are actually what you used up here. Something to take note of when you're doing shaders: anything that isn't used in your shader is going to be removed from the code when it compiles it for better efficiency. So if you're trying to set a value for something that isn't used in your C# code, for example, if you had set value for some other variable here with a different name, obviously, and a different variable here, then you'd have to make sure that it's actually being used, because otherwise you'll get some kind of null exception error, because you can't pass a value to something that's actually been taken out of the effects after it's compiled. It'll be taken out if it's not actually used. So anytime you have something that you're temporarily not using, just go like that. And then when you need to use it again, definitely remember to uncomment it. Make sure you add your QuadEffect.fx with edit add. And then once you've done that, try to build it. If it doesn't work, probably have a bug in it. So for errors, it's saying unexpected token found F, expects a semicolon, so there's a semicolon missing before the letter F at line 10. At line 39.3, it's also expecting a semicolon. So let's look at 10 and 39. We'll go to Tools, Options, and go down to where it says Text Editor, and select all languages, and we'll turn on line numbers. We'll just remember to turn that off after. So line 10 is right here. It says there's an F here, it's expecting a semicolon. So that means that we forgot to put a semicolon here to say that we're done with our line about the sampler. And then line 39, it's found a semicolon, it's expecting a close bracket. Okay, so that basically means we made exactly the opposite mistake. There shouldn't be a semicolon here. So we'll go back into content again and click build. Oops, do we save it? Make sure to save first. Invalid subscript text chord, 2 R's, so there's a misspelling there. So that would have been on this line. I just spelled it wrong here. Build it again. Undeclared identifier text chord on 2420. Oh, here it is. This should have a D. Build it again. Sprite Vertex Shader. Oh, it's missing an X. All these typos. So this is missing an X. Build it again. And Sprite Pixel is missing an R. That's crazy. Okay, it should be good now. So we're going to want to test out, say, our draw quad or draw rectangle fill or draw line or whatever. So we'll test out some of our primitives. And you'll notice that in our tiles1 image, we don't actually have anything. We don't have a white square filling up the space. We could put one there, but we already do have white over here. Let's open up our info box here, and we can see that that exists at 896 and 0. So let's just make a quick modification to quad batch. So make a public rectangle pixel here. We'll find the pixel here, and I suppose we'll have to capitalize this one. Alright, so we can just get rid of this line here, copy it, and we'll set the default for that one up here. However, we're going to want to override it in game 1. So right after we set up our quad batch, let's make sure to set its pixel is equal to new rectangle 896.011. That should do it. Now, let's make sure we didn't break anything else. Yeah, we'll get rid of that one. And we'll have to change pixel here so it's capital when that's passed in. And here as well. That should be it. And since we're not going to be using line numbers, I'll just turn that off quick. Options, line numbers off. We'll go into game 1 and we'll test our draw. Go down to where it says draw tiles, and right after the sprite batch end, add this quad batch.begin tiles image. We'll use blend mode alpha blend and sampler state linear clamp. Defaults to linear clamps, you can probably just do this. And we're going to draw using a source rect, which will be that white square, at the position 100, 100. Scale of 50 horizontally, 50 vertically. In the rotation, colored white. It'll be white square normally, but because it's white, we can make it any color we want. So let's make it red. And we'll test it out, see if it makes a red square. And it does. Alright, we'll test out maybe some other primitives, like we'll draw a line at 100 for 10, 10 to 500, 500, color.red, and just leave it 1 for thickness. Try it out. Okay, that worked. I noticed there seemed to be a slight issue with the sampling along the edge of this, so I'm just going to do a quick test here to see if there's some transparent pixels along the edge or if it's sampling wrong or something. So I dropped this layer behind it, trying green. So yeah, there doesn't seem to be anything wrong with the white square. These pixels are completely solid, so that's not the issue. Remember too that if you do make any modifications to the image, do it in your original file, and then after save it to the PNG in the content folder. Always work on your original. Don't load up the PNG and work on it, because you can end up losing information, and thus you will end up gradually degrading the quality of your image. Okay, so apparently it's having some problems with sampling at the edges. I'm not sure why, but we can use 897,1 for width of 2, height of 2, and we can use the simpler version where we're not specifying the rectangle. Should work just the same. Oh, it's got a bug. Let's find out what's going on. Oh, I know what the bug is.